Hello, Mr. Melu here, online math teacher, and welcome to my channel. Today we're going to be continuing my video series on trigonometry, and in particular looking at some applications of the addition and subtraction identities. So if you find this video helpful, consider hitting the like button and subscribing, and let's go. Now, if you have not watched my video yet on how to prove these identities, I'd recommend you go and watch that, because it's always a good idea to have a idea on where these come from. If you just blindly apply things without understanding where they come from, you're never really going to have as good of an understanding as you should. But if you have, we're going to get going and look at 3 different types of application problems your teacher is likely to ask you. The first of these problems is just asking you to evaluate a trig function using your addition and subtraction identities. So here, I want to know what sine of 7 pi over 12 is. 7 pi over 12 is not one of the nice angles on the unit circle, and it's definitely not coterminal to one either. So you can't just look at the y-coordinates of your points that you already know on the unit circle. But we also don't want to just plug this into our calculator and approximate with a decimal. So we want to know, how can we use the addition and subtraction formulas to be able to evaluate this exactly? So if I could break up that 7 pi over 12 into either the sum or difference of 2 angles that are nice angles on the unit circle, then I would be able to apply one of my formulas and evaluate. Now, students tend to find working with radians harder than degrees. So if you really are just not comfortable with the radians, you could always convert 7 pi over 12 to degrees, but then you'll also will keep yourself from ever getting comfortable with radians. So what I always recommend my students do is stay in radians if the problem is in radians. So we want to know how we can break up this angle of 7 pi over 12 in terms of angles that we know. And here's my tip for how you would do something like this. You could start out by saying we want to break this up into 2 things over 12 in terms of pi. And these are not necessarily simplified, but it'll allow us to start thinking. And typically we have our nice values on the unit circles have denominators of 6, 4, 3, 2, or 1. So these should simplify down to values with those denominators. And if I'm looking at this, I might realize that one nice angle I have is 9 pi over 12, because this would simplify down to 3 pi over 4, and another nice angle I have is 2 pi over 12, because that would simplify to pi over 6. Now, when I do 9 minus 2, I have 7. So 9 pi over 12 minus 2 pi over 12 will give me 7 pi over 12. So this is a difference that's equal to my angle of 7 pi over 12 that I want. And even better, if I think of this as simplified now, I have 3 pi over 4 minus pi over 6, both of which are nice angles on the unit circle. So what I can do now is just directly apply my difference formula for sine to have my values here. So now everything's in terms of either sine or cosine of 3 pi over 4 or cosine of or sine of pi over 6. And since I know my points with an angle of pi over 6 and 3 pi over 4 on the unit circle, I can just replace sine of the angles with the corresponding y coordinates on the unit circle, and cosine with the corresponding x coordinates to the angles on the unit circle. And now that I've done that, it is just basic algebra to get root 6 over 4 minus, or plus, because the 2 minuses, root 2 over 4, and your teacher probably wants you to combine these to just write this as 6, or root 6 plus root 2 over 4. So here's how I could evaluate it. Now, I stayed in radians this entire time using my trick at the beginning. Like I said, if you're not comfortable with radians, you could always rewrite this problem in terms of degrees. So like I did here, I could always rewrite the angle as 105 degrees and see it's 135 degrees minus 30 degrees is what I could use inside. And that's the same as what I had here in radians. Now, in my class, my students would lose a little points for this, but your class might be very different than mine. I'm just a stickler with staying in radians when you're in radians and degrees when you're in degrees. So evaluating is the first thing your teacher will likely ask. The second thing they'll ask you to do is to write an expression in terms of sine, cosine, or tangent angle. So you'll take something bigger that's more cumbersome and compress it down to make it look nice and neat in terms of our trig functions. So in this example here, I can see that this is a direct application of the difference rule for tangent. So this is going to be exactly the same as looking at tangent of pi over 5 minus pi over 3. So this was a direct application of my difference rule for tangent. Now your teacher is going to want you to combine those fractions inside of tangent. I guarantee it. You can do that by finding a common denominator. In this case, the easiest common denominator to pick out is going to be 15. So you will have 3 pi over 15 minus 5 pi over 15. And this is going to leave you with a tangent of negative 2 pi over 15 in this problem. So this is a much more nice and condensed down version of what you started with. So this is the second type of thing your teacher will ask. The third type of problem will be a proving of an identity or a simplifying an identity. So it's very common that we're going to prove identities with addition and subtraction formulas. And whenever you see something that's maybe a 2x, a 3x, a 4x, a 5x on the inside, you might think, I can use an addition and subtraction formula here. So while both the left and right look complicated here, when you start having angles that are multiple, higher multiples like 3x, 4x, 5x, 2x inside, that's going to make that side more complicated. So I could start out with my left-hand side here of cosine of 3x. And a very common trick that I require my students to use is to break up 3x using it as 2x plus x, because this is going to allow you to get it and use your addition formula. So I've done that here. Now, I can then take it a step further. I don't want anything with 2 x's in my final answer. And at this point, my students don't know the double angle identities, although they're really just a consequence of these addition subtraction formulas. So I can then use my same trick and rewrite 2x as x plus x. And now that I've done that, I can see 2 clear places where I can apply addition identities once again. And from here, now everything, I've gotten rid of those 2x's inside. I should combine any like terms and distribute the sines and cosine to get the following, where again, I have more like terms I can combine with this sine squared x cosine of x to give me cosine cubed of x minus 3 sine squared of x times cosine of x, which is exactly what I wanted to prove at the beginning. So this is my right-hand side, making this proof complete. So these are the 3 applications your teachers are likely to ask you. I hope you found this video helpful, and if you did, hit the like button and have an awesome day.